Hello friends, today I am going to discuss analysis of varying bars having different cross-sectional area. When you apply a load on a material, there is a different cross-sectional areas. म्हणजेच काय आतापर्यंत आपण जे स्टडी केलेलं आहे त्याच्यामध्ये फक्त एकच क्रॉस सेक्शन एरिया आपण घेत होतो. A is equal to pi by 4 d square for circular, A is equal to b into d for rectangular, A is equal to side square for square. हे आपण आतापर्यंत घेत आलेलो आहोत. पण आता आपण स्टडी करायचं आहे, जर आपण कोणत्याही मटेरियलवरती फोर्स अप्लाय केल्यानंतर त्या मटेरियलमध्ये किंवा बॉडीमध्ये जर डिफरंट क्रॉस सेक्शन्स असतील, जसं या डायग्राममध्ये तुम्हाला दाखवलेलं आहे, तर त्याच्यामध्ये कोणकोणत्या प्रकारचे चेंजेस होतात, चेंज इन लेंथ, स्ट्रेस कसे डेव्हलप होतात, स्ट्रेससाठी कोणता आपल्याला एरिया घ्यावा लागतो, चेंज इन लेंथ अपॉन ओरिजिनल लेंथ आपण जे घेतोय, स्ट्रेन कॅल्क्युलेट करण्यासाठी आपल्याला काय करावं लागतं, हे सगळं डिटेलमध्ये आपण या व्हिडिओमध्ये स्टडी करायचं आहे. आता अनालिसिस ऑफ बार्स ऑफ वॅरिंग क्रॉस सेक्शन्स. Consider a bar of different length, area of cross section and diameter subjected to axial load of P as shown in figure. Here is one diagram. In that diagram that is shown three different sections. A1 is the first cross sectional area, A2 is the second cross sectional area, and A3 is the third cross sectional area. L1 is the length of first section, L2 is the length of second section, and L3 is the length of third section, and axial load P is acting on that body. The stress and deformation length caused by each section's bar are different. Even if the axial load acting on the bar is same. It means if we apply load P on different cross sections, then stress acting on each section is a different, and there is a change in length is also different. Means आपण जर लोड सेक्शन 1 वरती P जरी लोड अप्लाय करत असलो तरी त्याच्यामध्ये चेंज इन लेंथ जो आहे तो सेक्शन 2 पेक्षा आणि सेक्शन 3 पेक्षा डिफरंट मिळेल, कारण त्याचा क्रॉस सेक्शनल एरिया जो आहे डिफरंट आहे. सेम सेक्शन 2 साठी आणि सेम सेक्शन 3 साठी. म्हणजे प्रत्येकाचा चेंज इन लेंथ जो आहे आणि प्रत्येकावर जो स्ट्रेस ऍक्ट होणार आहे तो प्रत्येकावरचा स्ट्रेस आणि चेंज इन लेंथ हा डिफरंट असेल, कारण प्रत्येकाचा क्रॉस सेक्शनल एरिया आणि लेंथ जो काय हा डिफरंट आहे. टोटल चेंज इन लेंथ मीन्स त्या बॉडीमध्ये जर टोटल चेंज इन लेंथ आपल्याला कॅल्क्युलेट करायची असेल तर आपल्याला प्रत्येक सेक्शनचा चेंज इन लेंथ ऍड करावा लागेल. दॅट मीन्स इज इक्वल टू सम ऑफ चेंज इन लेंथ ऑफ सेक्शन 1, सेक्शन 2 अँड सेक्शन 3. दॅट इज DL इज इक्वल टू टोटल चेंज इन लेंथ इज इक्वल टू DL1 प्लस DL2 प्लस DL3. Analysis of section 1. Stress in section 1. Let us consider the only single part, that is section 1. Load is acting on that part is P axially pull. A is equal to area of cross section A1. Therefore sigma 1 stress acting on the first section is equal to load upon area, where load is equal to P and area is equal to A1. Strain in section 1. Strain is denoted by small e. E1 is equal to change in length upon original length. Change in length is DL1 and original length is L1. And therefore change in length of section 1 is equal to DL1 is equal to PL1 divided by A1E. In last lecture we have studied change in length formula, that is PL upon AE. It is only change is suffix is given L1, L2, L3, A1, A2, A3, that are notations are changed because cross sectional area are changing. Analysis of second section. In second section, length of section is L2 and area is the L2. Load remains constant, that is load axial load is P. Stress in section 2, that is sigma 2 is equal to load upon area is equal to P upon A2. Similarly strain is equal to DL2 upon L2, and similarly change in length DL2 is equal to PL2 upon A2 into E. Similarly we will do for the third section. Stress in section 3 is equal to P upon A3. Strain is equal to DL3 upon L3, and change in length is equal to DL3 is equal to PL3 upon A3 into E. Now we have to add all the change in length to get the total change in length of the body, that is dl is equal to dl1 plus dl2 plus dl3. Put the value of dl1, dl2 and dl3 were calculated above, that is dl1 is equal to pl1 upon a1e plus dl2 is equal to pl2 upon a2e and dl3 is equal to pl3 upon a3e. Now p and e are the common. p and e कॉमन घेतल्यानंतर आपल्याला इक्वेशन मिळेल l1 upon a1 plus l2 upon a2 plus l3 upon a3. If value of E is different, that means the first section and second section and third section are made up of different materials. Then their Young's modulus of elasticity are different. That is E1, E2 and E3 are also different. Then we cannot take it as common. It is put as a same. Therefore, dl is equal to L1, P into L1 upon A1 E1 plus L2 upon A2 E3 plus L3 upon A3 E3. This is the, for E is the different, that is Young's modulus is different असेल तर आपल्याला हा लास्टचा इक्वेशन यूज करावा लागेल आणि जर यंग्स मॉड्युलस सेम असेल तर लास्ट सेकंड इक्वेशन आपल्याला प्रॉब्लेम साठी यूज करावं लागेल. आता हाय झाले फॉर्म्युल्यावर आपल्याला काही प्रॉब्लेम्स स्टडी करायचे आहेत. प्रॉब्लेम्स एकदम सिंपल आहेत, फक्त हे फॉर्म्युले तुम्हाला माहित असले पाहिजेत. Some important formulae to solve such types of problems that are we are discussed in the last lecture, that is change in length is equal to dl is equal to pl upon ae or ea. If E is same, then change in length for different cross sections is equal to P upon E into bracket L1 upon A1 plus L2 upon A2 plus L3 upon A3. If E is different, that is each section made up of different material, then DL is equal to P into bracket L1 upon A1E plus L2 upon A2E plus L3 upon A3E. Now we are going to solve some numericals on it. First numerical: a mild steel bar 6 meter long is 30 millimeter in diameter, of 2 meter length and 20 millimeter diameter for the remaining length. It is subjected to tensile load of 60 kilonewton. Calculate the change in length of, and its modulus of elasticity is 200 kilonewton per millimeter square. First we have to note down all the given data. What is given? A mild steel bar of 6 meter long. Total length is 6 meter and 30 millimeter in diameter of 2 meter length. That means first diameter is 30 millimeter for 2 meter length and 20 millimeter diameter for remaining length, means 20 millimeter diameter is for 4 meter, that is 4 plus 2 is equal to total 6 meter length. It is subjected to tensile load of 60 kilonewton. Axial load is 60 kilonewton, that is shown tensile, that is away from the center. 60 kilonewton. Calculate the change in length. We have to calculate dl and its modulus of elasticity, that means E is given. E is equal to 200 into 10 raised to 3 because kilo. E is equal to 200 kilonewton per millimeter square. And load is also in kilonewton. First we have to calculate L1 is equal to 2 meter, that is 2000 millimeter. L2 is equal to 4 meter, that is 4000 millimeter. D1 is equal to 30 millimeter, small d is equal to 20 millimeter. We have to calculate areas of these two sections. A1 is equal to pi by 4 into 30 square and A2 is equal to pi by 4 into 20 square. These are the two areas of different sections. And these values we have to put into the our change in length equation. dl is equal to total change in length of mild steel bar. dl is equal to dl1 plus dl2. Here the load P is common load and E is common because both the sections are made up of same material. Therefore we are going to take common P and E. P divided by E is equal to into bracket L1 divided by A1 plus L2 divided by A2. P is given in terms of kilonewton and E is also given in terms of kilonewton. Kilo gets cancelled, therefore 60 divided by 200. Into bracket, put the value of L1 2000, cross sectional area of A1 706.85 plus 4000 divided by 314.15. If we solve this, then we will get 4.668 millimeter as a change in length. This body gets elongated by 4.668 millimeter. Now, second problem. A brass bar having cross section 100 millimeter square is subjected to axial forces of 50 kilonewton as shown in figure. Find the total change in length. This is the brass bar having three different cross sections. One has the diameter 30 millimeter, 10 millimeter and 20 millimeter, and the length is 500 millimeter, 200 millimeter and 800 millimeter. And Young's modulus is given E is equal to 1.05 into 10 raised to 5 Newton per millimeter square, and load is given 50 kilonewton. First we have to write down all the given data, that is load is equal to 50 kilonewton, 50 into 10 raised to 3 Newton, E is equal to 1.05 into 10 raised to 5 Newton per millimeter square, length of first section AB is equal to 500, BC is equal to 200 and CD is equal to 800 millimeter. And we have to calculate the cross-sectional areas of each section, A1, A2 and A3. Area of cross section of AB is equal to pi by 4 into d square, that is diameter is 20. Area of cross section BC, diameter is 10 and CD is diameter is 30. Similarly, we have calculated all the areas of different cross sections. Now there is a change in length is equal to sum of all the change in length. Change in length of AB plus change in length of BC plus change in length of CD. Here are the formula. PL upon AE. Only suffix 1 to, instead of 1 2 we have written here AB, BC and CD. All the formulas are same. Again, in previous diagram, this is a load P is common for all the sections and this is made up of same brass material. Therefore, we are taking common as a P and E. P divided by E is a common. LAB divided by AAB plus LBC divided by ABC plus LCD divided by ACD. Put all the values. P is equal to 50 into 10 raised to 3, E is equal to 1.05 into 10 raised to 5. Put values of each length and cross sections, and if you solve it, we will get 2.51 millimeter as an extension, because this is a tensile force. If tensile load is given, there is an increase in length, that is extension. If compressive load is given, there is a decrease in length, that is compression. Again, third problem. A stepped bar is pulled by 20 kilonewton as shown in figure. Find the total elongation of bar if E is equal to 1 into 10 raised to 5 Newton per millimeter square. Here is the diagram, three different sections. First has 12 millimeter diameter and 1200 millimeter length. Second has 30 millimeter diameter and 2000 millimeter length, and third has 22 millimeter diameter and 1800 millimeter length. And these three different cross sections are axially applied by 20 kilonewton load, axially pull. First we have to write down the given data. P is equal to 20 into 10 raised to 3 in load. E is equal to 1 into 10 raised to 5 Newton per millimeter square. This is the common for all the sections. Delta L is equal to total elongation, means delta L1 plus delta L2 plus delta L3. Now we have to calculate the areas of three sections, A1, A2 and A3. First diameter is 12, second is third and third is 20. We have to put these values into equation, pi by 4 into d square, and calculate all the areas of different sections, first, second and third. L1, L2 and L3 are given 1200 millimeter For first section, second section 2000 millimeter, and third section is 1800 millimeter. Put this value in equation. Delta L, the change in length, is equal to PL1 upon A1E plus PL2 upon A2E plus PL3 upon A3. Here P and E are common. Take it out from the bracket, and L1 upon A1 plus L2 upon A2 plus L3 upon A3. And put all the values into this equation. We will get 3.83 is the total elongation of the bar. Problems are simple. Only we have to calculate the cross-sectional areas of each material, the length of each material, and put it into the our change in length equation, because load is given and Young's modulus of elasticity is also given. And next problem is a bar PQR is shown in figure. Find the elongation of bar E is equal to 20 into 10 raised to 4 Newton per millimeter square. Here is the bar is given. First bar is 300 millimeter long and 50 millimeter diameter, and second section is 30 millimeter external diameter and 25 millimeter internal diameter. Therefore, cross sectional area, this is a hollow pipe. We have to calculate this cross sectional area by pi by 4 capital D square minus small d square equation. And length of second section is 500 millimeter. Load P is given 70 into 10 raised to 3 Newton. A1 is equal to pi by 4 into 50 square. This is the A1. L1 is equal to 300 millimeter. Now we have to calculate A2. A2 is equal to pi by 4 into 30 square minus 25 square. We will get 215.98. And L2 is the 500 millimeter. Now put these values into equation. DL is equal to DL1 plus DL2. Again P and E are constant. Therefore equation is P upon E into bracket L1 upon A1 plus L2 upon A2. Put all the values P, this is E, L1, L2, A1 and A2. Again by solving this equation we will get 0.86 millimeter as a change in length. Thank you.